is CORDIScovery. Hello, welcome to this episode of CORDIScovery with me, Abigail Acton. Let's talk about the industrial use of drones, the technical challenges and the practical benefits. The numbers of those vast turbines off some of our shores are set to increase as we step up the drive to increase renewable sources of energy. But who checks the blades to make sure they're holding up to the impact of weather and wear? Drones can save people the hazardous task of manual inspection, both over the open sea and in it. If you're checking the structural integrity of a ship, what is the benefit of using drones, crawlers, and autonomous devices instead of engineers and mechanics? Can real-time sensing lead to quicker decision-making and less downtime? It's a good job I have two guests whose projects have been supported by the EU's Horizon 2020 programme, who are perfectly placed to answer these and other questions. Welcome to CEO of BladeInsight, André Croft de Moura. He's interested in robotics and data solutions applied to renewable energy generation. With his background in marine biology and oceanography, André's current focus is on how to improve the structural analysis of blades on offshore wind turbines. Welcome, André.
Thank you very much, Abigail. Thank you for the invite.
Super. Nice to have you with us. Alessandro Maccari, whose background is in naval architecture and marine engineering, is Research and Development Director at RINA Services in Italy. Alessandro has been applying his expertise to the challenges posed by the use of autonomous vehicles in ship inspections. Hello, Alessandro.
Hello. Thank you.
You're very welcome. André, let's move to you. Your project, Windrone Zenith, has been working on developing completely autonomous drones that can inspect all three blades on wind turbines, and you're focusing on offshore wind farms. Can you tell me the main technical challenges that confronted you with this?
Absolutely. So in the field of robotics, specifically for autonomy, what we're trying to do is to enable machines to have an accurate understanding of their environment and being able to react to it in real time. So as people, we are used to using our eyes, our perception, our feel to navigate the world in a way that is very intuitive to us. We don't have to think about it, and our brain does an amazing job at processing this in real time, which means that we don't fall over objects, we're in balance, and we usually get to where we try to go. Now, when we try to pass on some of these abilities onto robots, the biggest challenge is, can we empower them to do specific tasks in a repeatable, robust, and safe way? And over the past 10 to 15 years, the advancements in sensors have been immense. And so what this means is that sensors such as LiDARs and cameras and depth cameras have meant that we now have the ability to give processing units information, enabling them to react in real time. And this is very important because especially in real world environments and outside, you don't have time. Lag is a very big challenge, right? Because you have to be able to carry out these operations in a very swift way. And with that, I would bring the second big component, which is processing power has increased immensely.
So that means that the information that you're getting back from the devices, you can process it faster and more in depth, as it were.
Correct. So if the sensors are the eyes and the nose of the robots and the ears, then the brain power, which is how quickly we can process that information, is critical. And this is even more so for drones, because in this case, the processing units are on the drones, and weight on drones are a critical factor because they affect the flight time. So we're able to pack more and more processing power in smaller and lighter packages. And so bring all of this together in a way that works robustly and repeatably has been the overarching challenge that we've been bringing together on the robotics side.
Right. And I guess for you, with your interest in blade structural analysis and reporting offshore, one of the challenges has been able to have a device that can actually inspect all three blades rather than just a couple. I mean, because that takes more time, right? I know that was one of your goals.
Yes. So we've been in the market of blade inspections since 2016, but we were inspecting one blade at a time. And
Right.
This blade had to be in a predetermined position. And this position was vertical. So in practical terms, what this means is that we were actually operating in a 2D environment because we could make very good assumptions about what this object that we were inspecting was. And going from there to inspecting the three blades means that the other blades are off at an angle, which in turn means that our perception of the world now needs to be in 3D. So it's actually one order of magnitude more complex to be navigating in a 3D environment rather than a 2D environment. We can see that in computer games, etc.
Yeah, and the duration of flight.
Correct.
I mean, how did you get around that? Because as you were just saying, it's vitally important that they're not carrying much of a load, because that will impact on the flight time, as you just said. I mean, inspecting three blades in 3D, as you've just described, must be much, much more time consuming. Is it 3 times more time consuming, or is it actually even more than the 3 times?
No, it is slightly less because you can save on the takeoff and landing time.
Yes, of course, they're out there. Yeah.
Exactly. Our approach has been, we actually don't develop the drone itself. The drone is off the shelf. What we do is we've developed a payload that we attach to the drone, enabling it, taking over its decision-making and enabling it to do this very specific operation. So the answer to your question is twofold. Is on one hand, we have to select from the market a drone that has the ability to fly the time that we need it to. And secondly, we have to make these packages as small and as light as possible. Small helps with it being aerodynamic and therefore having less resistance to the wind. And obviously the weight will have a direct impact on the flight time as well.
And how long has it taken you to get to the stage where you now actually do have the package, as you call it, the technology that will actually inspect all three blades?
So we started, the company started in 2015, and it took us to 2017 to be able to have our first operating prototype to do the one blade. And our project kicked off in 2019. And let's say that the 3D, although it's an order of magnitude more complex, it does build on some of the building blocks that we used in the first one. So really, we're at the culmination of around 7 years of development to get to the point where we are today.
Right, evolutionary process, basically.
Exactly. But the whole three blade was actually developed over the course of the Windrone Zenith project.
Right. I mean, that sounds like an enormous amount of work, very sort of intense activity to try and get to where you are now. What drives you and your team? What was the motivation to try and develop such a technology?
So I am the founder of the company, and the goal behind this was crystal clear. This comes from my understanding that making renewable energy ubiquitous is a priority for mankind. And the biggest single driver of that is to make renewable energy cheaper. If we can make the levelized cost of energy, of renewable energy, as cheap and especially cheaper than existing carbon sources, then we don't need to use environmental factors to convince the big decision makers to move in that direction. All the economic incentives align with the environmental ones. And that is why I thought that wind energy in particular is very well suited to fill this gap. In fact, wind energy is projected to become the world's largest source of energy by 2050.
Uh-huh.
And we're talking about a distributed source of energy, right? We're talking about millions of turbines across several countries and continents having to be continuously maintained individually. And so this implies a scaling of servicing and inspection and monitoring to pretty much an unprecedented scale. And what I found was that many of the existing methods of several aspects of a wind turbine were not optimized. And blades was, for me, an obvious one, because blades were being inspected either through rope work, which implies 1 or 2 technicians rappelling off a blade, and using a little hammer and a little point and shoot camera to inspect it, which is dangerous, expensive, and takes a long time. And here, this time component I'd like to bring back to the drone, because a turbine exists to run, to generate electricity. So the longer that it is not running, the more expensive the energy that you're producing when it is running on a yearly basis is more expensive, right? So time is an important element in wind.
Do you have any idea how much time is actually lost through inspection processes and repairs?
Yes. So mostly on the inspection, because that's where we focus on. You can inspect between 1 and 2 turbines a day. So you're talking about 4 to 6 hours per turbine if you're doing rope work. If on another hand, you do this with a drone, or a 3-blade solution, we're targeting 22 minutes per turbine.
Goodness me, that's a huge difference.
Exactly.
So that's a real saving of downtime. Yeah, no, fabulous. Very, very interesting. And this is obviously incredibly clearly compelling, and anyone listening must be really excited to hear about this concept. But are you seeing interest from operators themselves? What's actually happening in terms of the market? You're at prototype stage. Is anyone taking it up, wanting to go further?
It's very funny that you asked this, because we felt that since the very beginning, we've been pushing the industry's boundaries. So for the first couple of years, everyone, the market really wasn't ready for what we were doing, and nobody believed that drones would actually replace this. It must be said that overall, many industries, but wind, which I know they're slowly evolving industries, and so change has a cost, and the adoption of new solutions usually takes some time. So we had to convince the market that drones could do this, and today drones are the de facto way of doing inspections.
Brilliant.
So the uptake took some time, and now it is the most common way. So we've seen a lot of interest in the solution.
Oh, that's fantastic. That's excellent. I'm really glad to hear that. Alessandro, let me bring you in here. You're using drones in a similar sort of way, but in a very different context. Would you have any comments to make to André?
Yes, the question I have on the use of the drones, especially on the inspection of wind farm, is the reliability of the information taken, and if the inspection bodies and administration or legal entities that have to verify the compliance of the inspection are easily using this data, or there is a regulatory barrier to be overcome in using drones for the remote inspections?
Thank you for the question, Alessandro. I think that's a very poignant one. So in the industry where we operate, there is no global standardized way of how inspections need to be carried out, or a threshold for that acceptance from a regulatory aspect. What exists are self-imposed quality standards from the different manufacturers and from different clients. Now, this isn't universally true. Germany has mandatory statutory inspections. France has just enforced them. So there is an industry push towards trying to make these inspections much more standardized. I have to say that it is a challenge. So today in Germany, drones are not accepted for visual inspections of blades. And this comes to one of my previous points of there needing to be a modernization and a push towards accepting these new methods of inspection, because everyone benefits instead of increasing cost to the industry. However, we can tune quality, we can tune sensors, and we are giving defect location and resolution, which we believe is much higher than what an inspector can do on the blade, which is one of the big advantages, I think, of a drone. So instead of having someone on a blade that will register what he wants to register and can register on that day, and this will vary per person, per day, per site, per blade, we capture the full surface, which means that we can share this information between many inspectors, have many different, and it makes the information much more accountable, comparable, and takes me to my last point, which is this is all to push the industry towards making data-driven decisions.
Alessandro, I think that probably really strikes a note with you, because I know that your project, the Robins project, has made the use of crawlers and drones more viable for ship inspection, and you passionately believe that these tools are the way forward for the industry. Thank you, André, but I'm just going to turn to Alessandro for now. What are the steps involved in ship inspection, Alessandro, currently, and what are the drawbacks of those more traditional methods?
Yes, well, class inspection, classification society inspection, and surveys on ships have the primary goal of confirm if a ship or the structures of a ship and all the components, I mean the mechanical, electrical components, are fit for purpose or contain defects such as corrosion, cracking, buckling, or coating breakdown. So the inspections are required to verify the vessel's condition with close-up surveys, and this is valid for, let's say, for all ship types, including naval vessels, but also fixed and mobile offshore units. And this is the field where probably we are somehow closer to the application of the wind farms. So there are a variety of possible inspections on board. You may have the inspection of uppermost elements, like the top of the masts or cranes that you have on specific cargo ships, the top part of the funnels, the exhausts, but also radars and communication equipment. But on the other hand, you have also the need to go inside confined spaces, and the confined spaces also could be dangerous spaces or hard to reach, could be tanks or ballast spaces that contain ballast water, seawater, void spaces, but also trunks and cargo holds.
Yes, so that the environments are diverse and range extremely from the exposed to the constrained. But what I'm curious to know about is, could you tell us a little bit about the status quo before the use of drones? In other words, what are the problems with using people? Why can't we just carry on using people?
Well, we will continue using people, but in a different way. In the last probably 5 years, the remote inspection have multiplied, I would say, exponentially, also boosted by the impact of COVID-19. And once upon a time, I could say that the marine surveyors had to go physically on board and access the areas where the inspection has to be carried out. And this requires a lot of travel, preparation, that is a problem of time and cost, because you have to prepare the spaces where the human being has to enter.
And I guess it could be hazardous sometimes.
It could well be. Imagine if you have to inspect, for instance, the cargo holds of a tanker or a ship that is carrying chemical products. You have to open the spaces, you have to ventilate, you have to check that the atmosphere can be breathed, or prevent any explosion problem, or even prepare some very specific equipment for the surveyors, like breathing apparatus and special protective equipment to go inside specific spaces.
Right.
So you may need scaffolding, you may need additional equipment in order to reach the areas that normally cannot be reached simply standing on a deck or climbing up a mast. So you can also imagine the safety and security problem that you have at the moment that, well, there is a physical effort also inside in these kind of traditional inspections.
Right. So that's clear then that there are obviously real drawbacks to just using people. Thanks for explaining that. So then the benefit of carrying these inspections out autonomously is evident. But how can a drone or a crawler identify the extent of an issue? For example, how can a drone verify that a patch of rust is superficially or is actually in fact structurally problematic? Can you tell us a little bit more about the sensors?
First of all, the drone has to reach the right position. And if it is a single point, like top of a mast, or a single spot inside the ship, that is pretty easy. But normally we have to also scan a very large surface, like the internal part of a tank or a cargo hold. So the drone or the crawler also has to follow a specific pattern in order to scan completely and systematically the surface. And this requires some preparation and also some pre-planned piloting of the equipment. Then, of course, you have to detect if there is just a spot of rust, if it is something, a dirty spot, or you have a much wider corrosion problem. So you need a very high quality video footage, for sure 4K definition for the footage, and also the possibility to map exactly where the defect is located. And drones or flying robots do not normally land on the surface and cannot get samples. This is the reason why, in addition to drones, we have also developed specific crawlers that are physically climbing, are attached with magnetic devices to the steel structure of the ship, and are able also to test, to probe, and even get some samples of the paint, of the rust, and do basically the same job that a human being could carry out inside the hold of a ship.
Yeah, absolutely. But also, as André says, without the subjectivity that a human brings to the task in a more objective way, because of course it's a machine, not a human. So it's following the program that you placed on it, rather than the inclination that a human might have. Because as André was pointing out, and I think it makes sense, that each engineer or each technician brings their own perspective to a task. So you get rid of the subjectivity, which I imagine is useful, no?
Well, subjectivity is pros and cons, because a very expert surveyor can immediately pinpoint or detect where you have the troubles and go straight there. For a machine, we may use machine learning and artificial intelligence in order to teach the robot on how to manage the inspection, to have some scrutiny of the difficult areas, and concentrate also the number of spots and the accuracy of the controls in the area that would require the maximum attention. This is the reason why the drones and the crawlers for ship inspection have to be very specific, not only in terms of reaching the point of interest, but also for the contact thickness measurements, and report the measurement in global coordinates in order to be able then to go straight there to start the repair work.
Right. And how does this data get shared?
So first of all, you need the possibility to connect via internet the ship to the rest of the world. And this is a big advantage. Managing the big data, of course, is the future. And the big data and the possibility to share in real time the information with any office around the world, the possibility to involve the key experts wherever they are, this is an incredible advantage, because basically on board you may have just one surveyor with a lot of experience, able to manage all the complex situation he may find on board. But if you get the data and can send the data in real time wherever it needs, you may have the top experts in the world that would be immediately available to process and to find the possible way forward. And basically, if you need to have an action done on board, or if you can maybe wait a little longer to have the repair work done during one of the scheduled stops of the ship. And this is also of paramount importance in case of accidents, where you can have immediate understanding of the situation on board and take the appropriate action.
Yeah. So, I mean, this again, it sounds so clearly advantageous, rather like Andre's as well. I mean, it's obviously the way forward. But are you having problems with regulators? It's a question I posed to Andre as well. How is industry taking this up, and are regulators embracing it, or are you having a problem trying to get your disruptive technology accepted by the status quo?
Well, the technology is giving a lot of opportunities, but we have a lot of barriers still to be removed to adopt these robotics and autonomous system inspection for ship safety. The data collected during the inspection, we know that can be securely acquired, transmitted, maintained, and used, but the regulatory framework is not fully ready to accept that. It is just a matter of, let me say, education. We have to use the technology use technology to eliminate some bureaucracy and convince, specifically flag administration, that the data acquired with the use of drones are as effective as the human surveyor in finding the right elements.
Yes. And so this is where I'd like to bring Andre back in, actually. So how do you feel about the future with regards to regulation? Do you think that it's around the corner, or do you think that it's going to be a struggle?
My understanding is that this is a two-way push. So on one hand, we need regulators to have the openness and the willingness to accept that there are overarching benefits if we can introduce more efficient tools. This will make the sectors in themselves more competitive, more streamlined. And secondly, I do think that the burden of proof is clearly on our side. So we are the ones that are changing the status quo. We have to prove the efficiency, we have to prove the benefits, and we have to do so in a consistent manner that brings the right entities into the conversation. And we understand these industries have operated for many decades. They are used to doing things in a certain way. And so it has to be our persistence and our data that has to be able to push it in the right direction. So it's the balance between these two things. But if no matter how much we do this, if there is no openness and there is no ability to adapt and to change from the regulatory, then it'll be too long a battle. And the problem here is that this might stifle innovation, right? Because we need the market to be there for us to offer our services.
Of course, yeah. Alessandro, I mean, the Robins project, which was your project that you were involved with, also had part of its goal to streamline acceptance and regulation. How did that part go? You were working, I think, with regulators a little, weren't you, to try and to make things easier, smooth bottlenecks?
Yes. I'm very glad that during the project in June 2020, we performed the world first statutory and class survey using live streaming remote technologies on a bulk carrier in operation. And after this remote survey, the flag administration was Liberia, that also attended the survey remotely, authorized the class society to certify the ship. And this resulted also in what we call a class notation that is enabling the operator, the ship operator, to perform additional periodical inspection using remote survey. And this is sort of a step forward towards the next digital level. The survey on this specific ship included the inspection of the hull and the machinery and the compliance with the applicable rules and regulations. And the close-up surveys of the ballast tanks, the seawater ballast tanks, and the cargo holds were carried out using drones. The excellent results that we got from this inspection is surely opening the way for a more systematic application to the shipping industry. The problems encountered were basically the connectivity kit, if you like, that is needed to ensure that we have a flawless 4G wireless connection in all areas on board. But for the ship owners investing in these, let me say, Wi-Fi technology on board is a pretty small investment that can translate into really huge savings, operational continuity of the ship, and higher revenues. COVID-19 then was a clear test bed for these technologies, and there is now a real take-up of this technology, especially in port state control, that is changing the mind about the possibility of systematically use these technologies.
I suppose that when you start to get a foot through the door, then that door will open further. If what you're showing is demonstrably better, then it's, I think, probably just a question of getting the initial uptake, and then I guess it'll snowball like most technology. What do you think, André?
I fully agree. I think there are tipping points, right? So I think success cases are what breeds, and I think Alessandro probably had a great success case in the trial and demonstration carried out. And those then align the stakeholders. So there is a number of people that have to see this as an advantage, and then they have to be convinced that the disruption it's going to cause to their existing methods is worth that cost.
In both cases, you're saving a lot of downtime, it sounds. Can I ask you both one final question? If you were to consider in 10 years' time, looking forward, 10 years' time, for example, how do you think your technology will be used, and what are the possible developments that most intrigue you? What do you see coming down the line? Things are changing so quickly. I'll go to Alessandro for that one.
Surely we will have many more pilots to fly the drones. And we will have perhaps less surveyors that are, let me say, wasting time just in traveling and going the most remote places around the world to go on board. And those experts can really focus their attention on the analysis of the results and cut all the unnecessary and costly problems that are related to the current state of the art. So in 10 years' time, there will be a shift in the specialization and a strong development of all these technologies.
Fantastic. Thank you. André, how do you see it in 10 years' time?
In our sector, I actually see it a little different. What we've seen is an industry where people had to do everything. Today, we have people taking machines to do most of the work, robots to do most of the work. What I see going forward in 10 to 15 years, and where we really want to take a part, is removing humans from the equation. So in our case, what we're talking about is resident drones at wind farms that should be fully autonomous beginning to end. What this means is that they should be an integral part of the operation and maintenance systems of the wind parks, so that not a single person is involved in the decision-making of launching it. So you could have a vibration that sets off an alarm in turbine X. When the wind is low, that turbine will stop. A drone will be deployed automatically. It will collect the data. It will go back to base. It will upload the data. That data will be automatically analyzed, and that will trigger an intervention if needed. If not, it will log it and add to the history of that turbine to be monitored in the future.
Of course, the contexts are quite different. I mean, you're both using the similar sort of technology, and I imagine probably the same sort of approach when it comes to data sharing and analysis. But of course, with Alessandro's case, there's lives at stake. If a ship is in trouble, it potentially can be dangerous for people. And for the wind turbines, it's a loss of power time, as it were. It's downtime. So there's a slight difference there. Maybe is why Alessandro is still seeing in his mind a role for the interpretation to be done.
And I also believe, if you may, Abigail, the turbines are extremely similar, and the repeatability, we're talking about one or two robots to cover an entire offshore park. Alessandro uses different robots for different contexts to find different things in ships that are all different between themselves.
Exactly.
So the repeatability and scalability is different.
Is a different thing. Yeah, and hence the ability to completely autonomize in your field, whereas for Alessandro, you obviously always see a role for humans with regards to the process of inspection.
Yes, absolutely. Drones can be typically operated by just one person without any extensive safety equipment, just with a general knowledge of the procedure. He doesn't need to be an expert in structural elements, in machinery, in rigging, in whatever, meaning also that the cost associated and the downtime can be significantly reduced, not only for the survey, but also for the ship operator. And then the data can be post-processed by the experts wherever they are in the world. And this probably is the greatest advantage of this new technology.
Right. Okay. Excellent. Well, listen, thank you very, very much for your time, both of you. That was a fascinating conversation, and it shows really clearly the benefit of using the drones and the technology behind them and the information that they gain, either hand in hand with human interpreters or in a completely autonomous world. Excellent. Thank you very much to you both.
Thank you very much, Abigail.
Thank you, André.
It was a pleasure.
For me too.
Thank you, Abigail.
You're very welcome, Alessandro.
An honor and a privilege, really.
Thank you. Lovely having you. Take care of yourselves. Are you interested in what other EU-funded projects are doing using drones and automated systems to broaden our view of the world around us? The CORDIS website will give you an insight into the results of projects funded by the Horizon 2020 program that are working in this area. The website has articles and interviews that explore the results of research being conducted in a very broad range of domains, from bacteria to bees. There's something there for you. Maybe you're involved in a project or would like to apply for funding. Take a look at what others are doing in your domain. So come and check out the research that's revealing what makes our world tick. We're always happy to hear from you. Drop us a line, editorial@cordis.europa.eu. Until next time.